The Kepler laws are the 3 laws of planetary motion that were discovered by Johannes Kepler. These laws, forming the basic foundation of astronomy, were published in 1609 and later refined by Isaac Newton in 1687. Before we jump into the details of the Kepler's laws, let's introduce the Copernicus model. The Copernicus model of planetary motion was first introduced by Copernicus in 1543. It was a replacement for the Ptolemaic system, which had been used for over 1,000 years. The Ptolemaic system had been based on the idea that Earth was at the center of all celestial bodies, and it accounted for their motions with complicated circular orbits around Earth. Copernicus argued that the Earth did not have a central position and instead, the Sun was at the center of our system, and that the planets orbit in a circle around it. It marked a major setback for natural theology, representing a paradigm shift in our understanding of the world. Kepler agreed with the Copernicus model but proposed some improvements, the first one known as the law of ellipses. This first law states that planets move around the Sun in elliptical orbits, with the Sun at one focus. This law results from calculations of the Mars orbit, which then helped Kepler to infer that other planets in the solar system orbit at an ellipse. The second law, also called the law of equal areas of Kepler, states that the imaginary line joining a planet to the Sun sweeps out equal areas during equal intervals of time. This law induces that the closer a planet is to the Sun, the faster it travels. Kepler's third law of planetary motion is a mathematical equation that states that the square of the period of an orbit is proportional to the cube of its semimajor axis. This captures the relationship between the orbital periods of the planets and their distance to the Sun. To conclude, as demonstrated by Isaac Newton in 1687, these laws are obviously consistent with Newton's laws of motion and law of universal gravitation.